Coastal ecosystem resilience, navigating climate challenges. Coastal ecosystem resilience, navigating climate challenges. The world's coastal ecosystems, rich in biodiversity and essential to human well-being, are facing unprecedented challenges due to the impacts of climate change. Rising sea levels, intensifying storms, and warming oceans are all contributing to the degradation of these fragile environments. However, amidst these challenges lies the potential for coastal ecosystem resilience, the ability of these ecosystems to adapt, recover, and thrive in the face of adversity. Understanding and enhancing this resilience is crucial for the survival of both coastal ecosystems and the communities that rely on them. The importance of coastal ecosystems. Coastal ecosystems, which include mangroves, salt marshes, seagrass beds, and coral reefs, provide a myriad of ecological services that support both marine and terrestrial life. These ecosystems serve as nurseries for various fish species, offer protection from coastal erosion and storm surges, and help mitigate climate change by capturing and storing carbon dioxide. Additionally, they are popular tourist destinations and contribute significantly to local economies. Furthermore, many coastal communities rely on these ecosystems for their livelihoods. Fisheries, aquaculture, and tourism are major industries that depend on the health and stability of these environments. Thus, the resilience of coastal ecosystems is intertwined with the well-being of human populations. Climate change impacts on coastal ecosystems. Climate change has intensified the pressures on coastal ecosystems, pushing them towards a tipping point. One of the most significant threats is the rising sea levels. As global temperatures rise, polar ice melts, causing sea levels to increase and leading to coastal erosion and the intrusion of saltwater into freshwater ecosystems. This has devastating effects on the delicate balance of these habitats, often leading to the loss of crucial biodiversity. In addition, the frequency and intensity of storms are on the rise due to climate change. Hurricanes, typhoons, and cyclones can cause immense damage to coastal ecosystems, breaking coral reefs, eroding shorelines, and destroying habitats. The destruction of these natural barriers can also result in increased damage to coastal communities during extreme weather events. Warming oceans pose yet another challenge. Coral reefs, often referred to as the rainforests of the sea due to their incredible biodiversity, are highly susceptible to bleaching events caused by warmer waters. Coral bleaching occurs when corals expel the symbiotic algae living within their tissues, causing them to turn white and become more vulnerable to disease. This phenomenon not only threatens marine biodiversity but also impacts the millions of people who rely on coral reefs for food and income. Building coastal resilience. Despite these challenges, there is hope for coastal ecosystems. Building resilience is key to helping these environments adapt and recover from the impacts of climate change. Here are some strategies that can contribute to enhancing coastal ecosystem resilience. These habitats act as a first line of defense for coastal communities and help maintain ecosystem services. 2. Sustainable management. Implementing sustainable fishing and aquaculture practices ensures that coastal resources are used in a way that maintains ecosystem health. Overfishing and destructive fishing methods can disrupt the balance of these ecosystems and reduce their ability to recover from disturbances. 3. Ecosystem-based adaptation. Incorporating nature-based solutions into coastal planning can enhance resilience. For example, designing living shorelines, stabilized, natural shorelines using vegetation, can help reduce erosion and provide habitats for marine life. 4. Community engagement. Involving local communities in conservation and management efforts is essential. Indigenous and traditional knowledge can provide valuable insights into the dynamics of coastal ecosystems and inform effective resilience strategies. 5. Policy and international cooperation. Global efforts to reduce greenhouse gas emissions are critical to mitigating the impacts of climate change. International agreements and policies that prioritize emissions reduction and support coastal ecosystem conservation can play a significant role in preserving these vital environments. The role of technology and research. Advancements in technology are also playing a vital role in understanding and enhancing coastal ecosystem resilience. Remote sensing, satellite imagery, and underwater drones enable scientists to monitor and assess the health of these ecosystems over time. This data helps researchers identify vulnerable areas, track changes, and develop targeted strategies for conservation and restoration. Furthermore, research on the genetic diversity of species within coastal ecosystems provides insights into their ability to adapt to changing conditions. This knowledge can guide conservation efforts by identifying species that are more resilient and better equipped to withstand the challenges posed by climate change. Conclusion. Coastal ecosystems are facing unprecedented challenges due to climate change, threatening both biodiversity and the well-being of human communities. However, the concept of coastal ecosystem resilience offers a glimmer of hope. Technology and research are powerful tools that can inform and guide these efforts, providing valuable data and insights into the dynamics of coastal ecosystems. In doing so, we not only protect the incredible biodiversity they harbor but also safeguard the livelihoods and well-being of millions of people who depend on them. Innovative approaches for coastal resilience. In addition to the strategies mentioned earlier, innovative approaches are emerging that hold promise for bolstering coastal ecosystem resilience. These approaches leverage cutting-edge technologies, creative designs, and interdisciplinary collaboration to address the unique challenges posed by climate change. These structures can mimic natural reefs and provide essential protection for coastal areas. By carefully designing these artificial features, engineers and ecologists can optimize their effectiveness while simultaneously promoting biodiversity. 2. Blue carbon projects. Blue carbon refers to the carbon dioxide stored and sequestered by coastal ecosystems like mangroves, seagrasses, and salt marshes. Implementing blue carbon projects involves conserving and restoring these ecosystems to enhance carbon capture. This not only mitigates climate change but also contributes to the overall health and resilience of coastal environments. 3. Floating communities and infrastructure. As sea levels rise, Some visionary architects and urban planners are exploring the concept of floating communities and infrastructure. These innovative designs involve constructing buildings, parks, and even cities on floating platforms. While this approach requires careful engineering and planning, it could offer a solution for adapting to changing coastlines and minimizing the impact of rising sea levels on human settlements.